Dear students, today we'll start our topic colloids. So before starting the topic colloids, we should know the comparison between the true solutions, colloids and suspension. So I have made one table, you can have a look uh, based on properties, okay, the true solution, colloids and suspension. The particle size of the true solution is normally less than 1 nanometer, whereas the colloids has the particle size of 1 nanometer to 1000 nanometer, whereas suspension has greater than 1000 nanometer particle size. Okay, then how they can be separated. Okay, the true solutions where how the solid particle of the from the true solution can be separated, or how the solid particle or the colloid, we call it colloid, can be separated from its medium or solution, or how the suspension particle can be separated from the dispersion medium, sorry. Now the separation technique. So ordinary filter paper, we have choose the ordinary filter paper. Okay, so before that we'll just look at the gravity, first one. So gravity, so true solution. So true solution, you can take the example of NaCl dissolved in the water, right? So what is the NaCl? Na plus and Cl minus, it ionized, right? So NaCl dissolved in water. Now you cannot able to separate NaCl salt from the water with the help of gravity. So through gravity separation, we cannot able to separate. Now in case of colloids also, one of the example you can take is a milk. Okay, colloidal solution. So milk, there is a protein particle present in a water, milk. So this protein particle do not settle down under gravity. You can keep the milk of a glass for hours or 2 hours or 3 hours. The particle do not settle under gravity. So that is the property of colloids. Now suspension. Suspension, you can take one example is sand in the water, right? So if you have a sand in a water, what will happen after some time? If you stir it properly and if you observe, after some time all the sand particles will settle at the bottom, right? Sand plus water, here is also NaCl plus water. So sand particles settle under gravity. So what I said is a gravity separation. Yes, it is possible. Suspension can be separated with the help of gravity. But colloidal solution, no. And true solution also, no. Now next is we'll check the ordinary filter paper. Whether ordinary filter paper can separate the solid particles from the solvent, or the dispersed phase can be separated from dispersed medium, no, right? So NaCl cannot be separated by ordinary filter paper. Similarly, the colloidal particle cannot. A few particle may be separated, but most of the colloidal particles pass through ordinary filter paper. But suspension, yes, you can separate the suspension particle from the solution, from the dispersion medium. Similarly, the ultrafilter paper. So can ultrafilter paper separate the particle? True solution, no. But yes, colloidal solution, yes. What is basically ultrafilter paper? Ultrafilter paper is the modified form of ordinary filter paper, where the porous size is very small, such that colloidal particles do not pass through it. Okay, so it gets separated. Similarly, suspension easily gets separated. Now centrifugation. The process of centrifugation can be separate the true solution. No, you cannot separate. Right? But colloidal solution, yes, through centrifugation we can separate. Okay, there is one machine, centrifugation machine is there. You have a test tube, and you have to pour that solution there, like milk, and you have to switch on the machine. Okay, it will rotate. Then after some time we can notice that the protein molecule particles, yes, they get separated, they get settled down at the bottom of the test tube. So in that way you can separate the colloidal particle. But suspension, yes, you can separate, right? So the category, in which category the true solution belongs to? The true solution belongs to the homogeneous category, whereas colloidal solution comes under the category of heterogeneous solution. Similarly, the suspension comes under the heterogeneous solution. You can refer to the page number 136 of NCERT book, chemistry book. Here it's a classification of colloids. First, number one is based on the physical properties, physical state, right, of dispersed phase and the dispersion medium. So on that category, if both are solid, then we can call it is a solid sol. Example, colored gas, gemstones, right, ruby and all. Similar, dispersed phase is solid, but dispersion medium, in which the solid is dispersed, then it is called sol. Example, paints, cell fluids. Solid in a gas, right, aerosol, smoke dust. Liquid in a solid is called gel, jelly. Liquid in a liquid is called emulsion, which is milk, right? Liquid in a gas is called aerosol, fog, mist. Gas in a solid is called solid sol. Remember, there's two solid sol. Gas in a solid is also solid sol. Solid in a solid is also solid sol. Similarly, solid in a gas is aerosol, liquid in a gas is also aerosol. Remember these 2 points. Similarly, gas in a liquid is called foam. So it's for the wiping cream, soap, leather, etc. Now, another important classification is based on the nature of interaction between the dispersed phase and the dispersion medium. Right. Under this category, we can categorize that in two types. One is called lyophilic colloids, another is called lyophobic colloids. Lyophilic means there is an attraction between the dispersion phase and the dispersion medium. If there is so it's called liquid loving, right? So there is attraction between the dispersion phase and dispersion medium. For example, you can take as a gum, gelatin, starch, right? So this mixed with a liquid, a suitable liquid like water. So these are called lyophilic salts, and these, remember, these are reversible. You can remove the dispersion phase from the dispersion medium, and after mixing again the dispersion phase with the dispersion medium, it becomes same as earlier. Okay, so these are reversible. Whereas lyophobic, phobic means hating, right? Liquid hating. So these are liquid. So there is no interaction, there is no attraction between the dispersion phase and the dispersion medium in this case. Okay, so how they are situated, how they are exist means, so we need to have something, it is called stabilizing agent, so that is required. Okay, because the medium and the medium or dispersion medium and the dispersion phase, suppose this is the dispersion phase, there is no interaction, so we need some suitable stabilizer to stabilize this particle, okay, colloids, this sol. So hence, so these are example of this is, you can take as a sulfur sol, gold sol, you can take as an example. Then these are, remember, irreversible sol. So once it is precipitated out, if you precipitate out this sol or colloidal particle, then it cannot again go back into the solution. So there are many techniques to precipitate out. We called it coagulations. We'll discuss in later sections. Another important classification is based on the particles of the dispersed phase, whether that is a multimolecular, macromolecular, and associated colloids. So multimolecular colloids means many molecules aggregate together and form a size of colloidal dimension. That is, we have already talked, that is 1 nanometer to 1000 nanometer is the colloidal range. So many molecules come together, okay, and form a aggregate together and form a colloidal particle of range, then it is called multimolecular colloids. For example, sulfur sol, gold sol, these are. Another is macromolecular colloids. So in this case, it is a single molecule but of colloidal dimension. Example is starch, cellulose, proteins, nylon. So this comes under the heading macromolecular. They have a single molecule of very large size that comes under 1 nanometer to 1000 nanometer of diameter range. Right. Now next is associate colloids. Now these are basically the true solutions. Okay, so they are electrolyte basically. But what happens is that at low concentration they behave as a true solution. But at high concentration, the molecules aggregate together and form a colloidal dimension. So the basic difference between the multimolecular colloids and associate colloids is in multimolecular colloids we do not talk about the concentration. At all concentrations they aggregate together and form a particle of colloidal dimension. But here in associate colloids, no, concentration is an important factor. Okay, so at particular concentration, below particular concentration they behaves as a true solution, and after particular concentration they aggregates together and form a particle of colloidal dimension, and that particular concentration is called critical micelle concentration, CMC. Okay. And that aggregated particle is called micelles, and the temperature normally that use above that particular temperature it is formed is known as Kraft temperature. Example we can take is a soap solution. So soap, we can take one of the example, sodium stearate, right? It's a C17H35COO Na. So this is the sodium stearate molecule. So 17 carbon plus 1, so 18 carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 plus 1, COO negative Na positive. So this is the sodium stearate molecule. Now we have learned in class 10 also. So this part is called tail, and this is hydrophobic in nature. So this is hydrophobic. Hydrophobic means it's a water repelling part, and this is called head. This sodium goes into the solution, so we don't talk about sodium. So this negative part, CO acetate ion, carboxylate, CO negative carboxylate ion. So this is called heat. This is hydrophilic in nature, right? So this is hydrophilic in nature, so we call it head and we call it tail. When the concentration is very low, then we have water. So this is our water. Then if we add a few soap solution, that means less amount of soap solution, so it is a hydrophilic part. So this is head. So it stays like this at low concentration. Okay, all the molecules come at the surface and the head is inside the water and tail is outside the water. But at high concentration, if the concentration of this soap molecules is increased, the amount of is increased, then it has to go inside the water because all the molecules cannot accumulate at the surface. Then it forms a micelle in which this hydrophilic part is outside and hydrophobic part is inside the spherical ball. Okay, it looks like a spherical ball. It is formed by the micelle. So this is called micelle. Now what is micelle? Micelle is a cluster of soap molecules in which hydrophilic part is outside the spherical ball and hydrophobic part is inside the spherical ball called micelle. Now this is the cleaning action of soap. We have also learned in class 10. Suppose this is a dirt or oil particle, then when we apply a soap molecule, so this is hydrophilic, hydrophobic. Now hydrophobic, this oil is also hydrophobic, right? So hydrophobic and hydrophobic, right? So this is your hydrophobic. So hydrophobic part and this hydrophobic attract each other. Okay, so it will attach this like this. Slowly when we agitate our clothes, okay, during washing, so it will come out and it will go inside that. So dirt or oil particle which is hydrophobic nature, that will go inside the micelle. Okay, and when we flush with water, all the micelle will go out from the clothes and the clothes becomes clean.